guys, welcome to another concept video from GMAT Guy. Without further ado, today's topics would be statistics and sequences. First part would look at statistics, and then we'll look at arithmetic sequences and stuff you need to know about sequences. It's an easy topic, but if you have a lack of time, this topic is one of the most frequently tested topic in GMAT, so I would recommend that if you don't have the time to study all the topics, this is one of the topics that you definitely should study to maximize your score in the GMAT test. Okay, the questions can be tricky, the application of the formulae can be tricky, but the things to remember, or the formulae to remember for this topic, is not tricky. They're very easy. Okay, so let's get started. Statistics is about basically handling a list of numbers, right? Handling a list of data that you will get. For example, let's say we're going to work with a list of 1, 2, 3, 4, 5. Simple list. And actually, let's just work with that. No worries. Now, the first thing you need to be able to do is calculate the mean or the arithmetic mean or the average. How do you calculate that? Very straightforward. You add up all the items in the given list, and so that you do total sum. Okay, and you divide by the number of terms there are. So in this case, you'll do 1 plus 2 plus 3 plus 4 plus 5, divide by 5, and you'll get the arithmetic mean. Great. All right. Second thing that you need to know is how to calculate median. Median is basically 50th percentile. 50th percentile means the number which is more than half the list, right? But it is less than the other half of the list. So it's right in the middle. So to do this, to calculate median, you have to arrange all your data, all the numbers in the list in an ascending order, in an increasing order, or in a decreasing order, right? In this given example, it's already arranged in an increasing order, so you don't have to worry about it. And the median, you're right, would be 3. It's the center number. Now for median, you have to remember that if there are odd number of numbers in the list, then it's the center one. Okay, so if there are if it's odd n, then it will be how many ever n you have, add 1 with, because you won't be able to divide it. Okay, so n plus 1 divided by 2, that's the term. N plus 1 term, n plus 1 divided by 2th term would be the median. Okay, so in this case it would be 5 plus 1 divided by 2, the third term, right? But what if there are even number of terms? So if there are even number of terms, let's say 1, 3, 8, 8, 9, 10. Okay, I've taken a bad example, it's quite evident already, but in case of an even number of terms, so when the n is even, the median is basically the average, okay, of the center 2 terms. Okay, so let's keep it easy. It's the average of the center 2 terms. But if you have like a huge list of 100 something numbers, then you need to be able to calculate which position is it, right? So what you do is you do n over 2, okay, that term, and n over 2 plus 1, so the next term. The average of these 2 terms would give the numbers, values would give you the median, right? The third thing that you need to know is how to calculate mode. Mode is basically the most frequently occurring number in the list. In the above example, 1, 3, 8, 8, 9, 10, it is 8. However, if you have a list like 1, 3, 3, 4, 4, 5, right? In this case, the mode is not the average of 3 and 4, it is 3 and 4. Okay, so just simple things to remember so that you don't go wrong there. The fourth thing you have to remember is range. Range is quite straightforward. Range is nothing but the difference between the maximum and the minimum number in your list. So if you have a list like 1, 2, 8, 10, 12, 15, the range here is the difference between 15 and 1, which is 14. Right? Easy. Great. The fifth thing that you have to remember in statistics and understand is standard deviation. So I'm not going to scare you, but there is no formula. It's actually a good thing. You don't have to remember the formula for standard deviation. All you need to do is understand what standard deviation is conceptually and what all can affect the standard deviation, and that's good enough to answer the GMAT questions. Okay, so let's say that you have two given data sets. I'm going to split the screen into two. Both the data sets have the same mean. So let's say we have two populations and the average, so population 1, population 2. And the average income, the mean income of both the populations is the same. It's $100. Okay, $100. All right. The mean is the same. The range can be the same. So let's say here the lowest is 1 and the maximum is 500. Same in population 2, minimum is 1, maximum is 500. Your median might also turn out to be the same. Let's say that the centered term is around here, which is 100. Okay, for ease of explanation, let's say that the median is the same, but the two populations can still have a very different dispersion around the average. For example, population 1 can have all the data sets really close to 100, a little more than 100, a little less than 100, while population 2 can have very wide varying dispersion. So let's say some data sets are all the data sets are far away, right? But as you can see, the difference between the two is very difficult to express with the four things that we studied before. Mean is the same, median is the same, who knows, let's say the mode is also the same, and the range is the same. But the dispersion of the data set around the mean is different. That's what standard deviation tells you. It tells you how far are the data sets from the mean on an average. So in the first population 1, the standard deviation is low. It's low because most of the data points, in the simple crude example that I've drawn, most of the data points are close to the average value of $100. So on an average, most of the data points are close by, the standard deviation is low. However, in population 2, the distances, on an average of each data point from the mean is quite high, is higher than in 1. In 1 it was just this much, right? And so we say that in second population the standard deviation is higher, okay, than the first. And so that is what standard deviation is. It is basically the average distance of the given data points in your list from the mean of that given set of data. All right. Okay. So here's one quick question, just to illustrate the concept of standard deviation a bit more. Let's say that I have 5 numbers, a list which has all 5 the same numbers: 100, 100, 100, 100. Let's say 4. Okay. What value? There is a fifth number. Okay, let's say there's a fifth number that is going to be added to this list. What should this number be so that the standard deviation stays a minimum? Right now the standard deviation is 0. You're right, because there is no deviation. All the data sets are at the mean, so the distance is 0 of each. The average distance of the data points from the mean is 0. But to keep it a minimum, what should be the fifth data point? You're right. If you add mean, that means another 100, the standard deviation will remain 0. Great. A key thing to understand here is the standard deviation does not become negative. Good. Now, what would be, if I give you 5 numbers in a list, A, B, C, D, E, as GMAT would do, you can easily pick the number which will increase the standard deviation the most, right? That's all. That is what you have to keep. You have to try to keep the concept simple. Understand what it is, and thereby you'll be able to, once you've understood it, grasped it properly, you'll be able to apply it when the time comes. Okay? Alright, so with that, statistics is done. Easy. Good. Now comes the second bit, which is sequences. In sequences, and first of all, what are sequences? Well, a number like this, a list like this, 1, 2, 3, 4, where you can look at the pattern and tell what the next number is a sequence. So here it will be 5. But if I give you a random list like 21, 53, 37, 16, 9, what is the next number? If there is no pattern, then this is not a sequence. Okay, now for GMAT purposes, we need to be dealing with two kind of questions. One is general sequences. Okay, general sequences. Now a general sequence would basically mean that it can have any formula, right? So let's say it has 1, next number is 4, next number is 9, next number is 16, next number is 25, and so on. Have you guessed what the sequence is? You're right, it is the squares. The formula for this would be, formula for like a given nth term, a general formula would be that nth term is equal to n squared, right? So what GMAT would do is that for a random sequence like this, they will give you the formula to play with, and then they can ask you to calculate things. For example, in this question, I can ask you, what is the average of the 50th and the 25th term of this sequence, right? I mean, this is of course, what you then do is you look at these, you calculate these two terms from the given formula, and then you calculate the average. So you get 50 square plus 25 square over 2, right? And that's your answer. You can simplify it or you can calculate it and get the answer. So that's what general sequences would do. You won't have to remember anything, but you will need to know how to use this general formula that they give, or the information they give, to apply and get the answer. Okay, that's one. Second one is the one where you actually will have sorry about that, the slide was not clear. The second one is where you will actually need to remember a bit of formula. The second one is arithmetic progression or arithmetic sequence. An arithmetic sequence is one where you keep adding the same amount, or let me actually give you a simpler definition, where the difference between any two consecutive terms is the same. For example, 1, 3, 5, 7, 9. The difference, as you can see, is 2 constantly. This is an arithmetic sequence. What are the formulae you need to know? Okay, the first thing you need to be able to calculate is the nth term. So let's say I have an nth term here. So this is first term a1, then you have a2. To calculate the nth term, the first term is very important, and this difference d is very important. Once you have these two quantities in an arithmetic progression, you can calculate whatever you need. How do you calculate that? Let me give you a small example. If I define this sequence or any arithmetic sequence in terms of just a1 and d, the first term would be a1, the second one would be a1 plus d, the third term will be a1 plus 2d, and so on, right? What do you notice? I just keep adding d to calculate each term. Notice what the formula is for the third term. The third term, which is the third term 3, has 2d's. The fourth term will have 3d's. So similarly, the formula for nth term, which is the first formula you have to remember, is a1 plus n minus 1 times d. Okay, once you've done that, if you remember just this formula, arithmetic sequence is mostly done. You don't have to remember much else. Okay, let me tell you some application of this, right? Some other formulae that you actually don't need to remember, but you need to know how I got it. If I want to add, let's take a look at this sequence. 1, 3, 5, 7, 9, 11. Okay? When I add the first and the last term, I get 12. When I add the second and the second last term, I get 12 as well. when I add the third and the third last term, I get 12 as well. You know why? Yes, because from the left hand side, as you go to the right, you add 1d, but when you go from the highest number down, you are subtracting a d. So they're kind of compensating each other. So what this means is that each pair adds up to the same amount. This can be used to calculate the average really fast. So another formula, if you want to remember, is that the mean of arithmetic sequence can just be calculated by the sum of any one of these pairs. So let's say the first term plus the last term divided by 2. That's the mean, and this is also equal to the median. Always, okay? So in an arithmetic sequence, the mean and median are always the same. This helps a lot, okay? The last thing you need to remember is how do you add them up? Well, so from this, you should have already guessed, sum of n terms in an arithmetic sequence is basically, you calculate what is the sum of one pair, because all the pairs are adding to the same amount. So what I do is I add up the sum of one pair, and most commonly the first and the last term are the easiest to add up. So what you can do is you can do first term plus last term, and then you multiply this to the number of pairs there are. How many pairs would there be? The number of terms, which is n, divided by 2. That's it. If you actually rearrange this, you'll realize that this is the same formula as statistics, where it is, not statistics, but really a1 plus a last divided by 2 is the mean. So this portion is the mean, and you multiply mean times the total number of terms, and you get the sum, which is what we looked at statistics, right? So there are two ways of looking at the formula, but they give you the same answer. Good. So with that, I think we've covered everything you need to know for statistics and sequences. Go out there and calculate some questions, get some right answers, and let me know. If you have any doubts, you can always contact me or drop a comment on my email address. Till then, see you in the next video. Bye-bye.